Okay, this is going to be part one of what is ground. Both with my day job and this guitar pedal job, I have a lot of people always asking me, um, how do I use ground? Everyone initially thinks that like ground is just ground, but there's more to it than that. There's different types of ground, and not all grounds are created equal. And there's more to it than just saying all ground goes to ground. Um, at the end of the day, typically they will connect to one another, ground one with ground two. But let's just take a step back, and you have ground right here, and this ground wire, I love this, goes to infinity. And if that's all ground is, it's just a wire. And it's a wire that's at 0 volts. Now, what makes this wire 0 volts versus just a wire? And the answer to that is potential. So you have 9 volts here. And this is your potential. So the difference between a wire and 0 volts is the wire has a potential around it. And you'll have a common area, which is another reason ground is called common, I'm guessing, is because that's a spot where everything meets and has a common reference. So that means everything knows where its 0 point is. 9 volts would not be 9 volts unless there was ground. Now, which I'm sure everybody's found out that if you short this out to here, it explodes. Not literally, but it doesn't like it. Smoke. And you still need to have some way to let 9 volts know where 0 volts is its reference. So you need to have your potential needs to have a reference point. And we do that with, components and, ICs, whatever you want. So the main takeaway from this is to know that voltage is nothing without having a reference point. And ground is not 0 volts unless it has a potential. Let's move into the guitar world. So here is your guitar, and your cable is coming out of your guitar, and inside of here is your signal. We'll actually go like this, and here's your guitar. Some of the best drawing I've done on these videos so far. You have your jack here. Here's your sheath, your cover, and this comes into here. Around this is your sheathing. And the center of this is your signal. So when that comes in here, you have the tip, and that tip has a sleeve. And this is the wall of your guitar pedal. To break this out, it looks like this. Here's your tip. This is your signal path. This is your ground. And as you take this off, open it up, there is your signal going here and your ground shield going there. On this thing, the shield goes all the way through, all the way around, and it protects your signal, your precious signal. It is the most important thing in all of this stuff, is this signal path. And the sheathing around that, which is technically ground. It's the ground over here, and it connects this ground to the ground on this wall here of this enclosure. And that enclosure can be a guitar pedal, an amp. I'm gonna go ahead and close this, and you can see that this goes all the way around, and there's no area of this where the signal path is not protected with this ground shield wire that comes through. And this is your guitar input, which equals signal and ground, just to recap. So on this side, you'll have your other tip, and this goes to the wall as well. So your shield goes directly into here, plus you have this metal. Trying to make a big emphasis on this. There is your signal ground, which is shielded, and it's outside of everything that you are working on inside of this enclosure. So it's covering this, and it's what we call in electronics a Faraday cage, which pretty much means it blocks out, noise, EMI, and the idea of it is the potential on the outside equals the potential on the inside, and it refracts any kind of noise that goes in and out of it. Let's keep going on this. Here's our DC power plug coming in, and that DC power plug comes into a 9 volts here and a ground. Now, this ground is not the same as this ground at this point, because this is our DC ground and DC potential. I get to use that word again, a full circle. This DC goes on to a board. I'm gonna do dotted lines. And it gives power to this board. Now, this signal path, goes through here, lands over there, or it'll go through here and go through some effects that is powered by this 9V DC. And the main goal is to not have this DC ground interfere with our signal path ground coming from the guitar. And a good way to look at this is to put these in pools. So we have our guitar pool here, and we have our DC pond here. This signal path ground is going all the way from this guitar into an amplifier, and it is in a perfect conditions. It's always protected by its ground on the outside. So that's our ground out here, signal path ground, shielding, enclosures. On the amp side, you get AC coming in, which equals a whole new arena. You have your earth ground, and they're all one massive cage that blocks out noise. The idea with having these ponds is this 9 volts here on this DC is eventually going to touch the ground on the signal path. So then it could have its reference that needs to be common between all of these things. It's not always directly connected, and that's why we have different types of ground, but it will have some kind of interconnection. So all of these devices have their common reference point. So our types of grounds, which people have probably seen already, have like common, which we're talking about. That's just like a really general term. You have your earth from a AC line. In this place, I called it IRCH. And you have your DC ground, signal path ground, which we've gone over already. So you have signal path, DC, common. You have shielded ground, drain. You have your analog ground, digital grounds. You'll see these inside of schematics. So we can take these different types of grounds and put them in their designated pools. These will all be connected in some kind of common fashion, but in some cases you want these grounds to be very close to each other or very far from each other, depending on what kind of isolation you have, because there will be introduced noise into your system. And there's certain parts of your system that want to have less noise. The way of doing that is you have your ponds and your lakes, and you isolate them via distance. There's a lot of different ways to interconnect grounds with one another. In our case here, our only common ground is between the ground on this plug and the ground on our DC. And for me, I keep mine really isolated. So my signal path ground is here on my jack. I'll just show you. My signal path comes here, and it connects. The signal ground is here, and that goes through my foot switch. And the DC doesn't connect until it's on this board, in which case I have my little PCB up here, which is one of my ponds. They're fairly well isolated, and we want them to be, because we're going to have a little pond here of DC, and we're going to continue our shield and our shielding lake that we have here. Ponds. And this little pond here, lake, not ponds, ponds.